Parallel lines have the same slope. Here we have a picture of two parallel lines. Often you will see arrows on the parallel lines to indicate that they never meet when extended on indefinitely. Let's look at the slopes of these two lines. I'm going to use a diagram to get the slope of this line. You could of course get, say, the coordinates of this point and plug them into your formula. Well, I won't do that here. It's quite easy to read off what the slope is. The horizontal distance between the points is 3. The vertical distance between them is easy to get. It's 1, 2, 3, 4, 5, 6. So I'll call the slope of this line M1. So we put rise over run, or y2 minus y1 over x2 minus x1. We get 6 divided by 3, which is 2. So the slope of this line is 2, and it's got positive slope because of its direction. Let's look at this line here. Say, get the slope using this point and this point. It's easy enough to see that this distance here is 3, and the vertical distance between the endpoints of this line is 6. So again, if we call the slope of this line M2, we see the slope is 2. 6 divided by 3 is 2. So this is not a surprising result. Two lines are parallel, it means they're pointing in the same direction, if you like. So if you were to imagine walking up one of these lines, imagine somebody actually climbing up this line, imagine it's part of a hill. It's going to involve just as much effort for the second line as this line here. If you wanted to see a proof of why parallel lines have the same slope, I mean a geometrical proof, we're given that these two lines are parallel, so this line here is a line, if we extend it, it's a line that's cutting across these parallel lines. This line is sometimes called a transversal, but you don't have to worry about that. Then this angle here and this angle here are known as corresponding angles. So we have a line, the blue line, cutting across two parallel lines. We form a pair of corresponding angles. Corresponding angles are equal. So we could call them A. So if this is A, then this is A. And this A here is the same as this A down here. Actually, these two are corresponding angles as well, because this line here, this horizontal line, is parallel to this line here. So we have another line cutting across parallel lines, so we have corresponding angles being formed. So these two angles are the same, and also of course a right angle is the same in both triangles. When we construct both of these triangles, we construct right angle triangles. And then we just have to go out a certain distance, like if we go out 3 units, say, from any point, or any distance we like, then we can do the same on our second line. We can go out the same distance, say 3. So if you know about geometry, we have an angle side angle situation. This is abbreviated to ASA. Now if you haven't heard about this, it doesn't matter. It's just for anyone who knows about this. This is an abbreviation for angle side angle. So if we have two triangles and we have, two angles the same in both triangles, and the line joining the corners of the two angles is also the same in both triangles, then both triangles are congruent. Congruent means that everything about the two triangles is the same, not just this angle side and angle, but also the other sides. So that means that this side here must equal this side. And from that we see that the slope must be the same. If this is the same as this, and this side is the same as this, then 6 over 3, the slopes will obviously be the same. But anyway, that's just an aside. Let's consider perpendicular lines. I've drawn two lines that are actually perpendicular to each other here. Let's call the slope of this first line M1 and the slope of this second line M2. Now it's a fact that the product of the slopes of perpendicular lines is -1. So if these two lines are perpendicular, then if we multiply M1 by M2, we should get -1. So we get the product of the slopes. That means we multiply the slopes of the lines together. So let's check to see that these lines are perpendicular. So let's get M1, the slope of this line here. Well, how do we do that? We can pick any 2 points on it and construct a right angle triangle. What I will do here is pick this point here, and let's see now, this point here. So you could work out this using your formula. This point here has coordinates -2, 4. This point here has coordinates 2, 1, and you could plug the values into it, but I'm not going to do that because we can get it quite easily from this diagram. So we can see that the vertical distance between the points is 3 units, the horizontal distance between the points is 4 units. So what is M1? Well, we put rise over run, 3 over 4. However, we must remember that this line has negative slope, so we have to stick a minus sign in front of it, in front of 3/4. Now let's look at M2. Let's see now. We pick this point here, go across here, come down from this point. See, this horizontal distance is 3, vertical distance here is 4. So we can see that M2 is 4 over 3. You can see that for perpendicular lines, one of the lines has negative slope, the other line has positive slope. You can see that if we multiply these two slopes together, we take -3/4, which is M1, and multiply by 4/3, which is M2, we end up getting -1. 4's cancel, 3's cancel. We have -1 by 1 is -1. So these lines are at right angles to each other. As an aside, I will quickly run through a reason that makes sense for this rule here. If you can imagine rotating this line 90 degrees anti-clockwise about this point here, what would happen? Well, this distance here, this blue distance, is vertical. So if we rotate a vertical line by 90 degrees, it will become a horizontal line. So we'll have a line that looks like this. It's 4 units long. And this line here, which is horizontal, when rotated by 90 degrees, it becomes vertical. So a vertical line becomes horizontal when it's rotated by 90 degrees. A horizontal line becomes vertical when rotated by 90 degrees. So you can see that the line that we get after rotation by 90 degrees has its slope inverted. The rise becomes 3 and the run becomes 4, whereas before the rise was 4 and the run is 3. So basically, to get the slope of a line that's perpendicular to a given line, we invert this fraction. We take 4 over 3, turn it upside down to get 3 over 4, and then we must change the sign, because perpendicular lines have opposite sign. So if this line has a positive slope, if we rotate it through 90 degrees anti-clockwise, we will get a line with negative slope. Anyway, that's just an aside. The key thing is to remember this fact. Let's finish with a quick example. Find the slope of a line that is perpendicular to the line passing through the points 3, 4 and 11, 7. Now you could use a diagram to help you do this question. I'll just use the formula for the slope of a line. Now we start by getting the slope of the line joining the points 3, 4 and 11, 7. So I will call that slope M1. So in the last video we used this formula here. So just plug in the values, label one of the points x1, y1, doesn't matter which one, label the other point x2, y2. So y2 is 7 minus y1, which is 4, divided by x2, which is 11, then we have a minus sign, then x1 is 3. So we get 7 minus 4 is 3, 11 minus 3 is 8. Now we have a line that's perpendicular to the line joining these points, and we know that the slope of the line joining the points and the slope of the line perpendicular to this line multiply to give -1. So if we call M2 the slope of the perpendicular line, how do we get it from M1? Well, the slopes must multiply to give minus 1. The only way that can happen is if m2 is minus 8 over 3. So we turn this number upside down and change the sign. That way, when we multiply m1 by m2, we will get minus 1. Let's see. If we take 3/8 and multiply by minus 8/3, everything cancels and we're left with minus 1. So minus 8/3 is our answer.